July 15, 1941. Chelyabinsk, Ural Mountains, Soviet Union. Tractor factory foreman Ivan Likachov stood in what had been an empty field 3 weeks earlier, staring at railway cars stretching to the horizon. Inside them, the disassembled remains of the Kharkov locomotive plant, 10,000 workers, and blueprints for building T-34 tanks. German panzers were 800 miles west and closing. His orders were simple but impossible. Restart production in 6 weeks using farmers who'd never seen a lathe, women who'd never welded steel, and teenagers who could barely lift a wrench. By December, they would deliver 25 tanks. By 1945, this single factory would produce 18,000 T-34s, more armored vehicles than the entire German Reich built during the war. The Germans never expected Soviet farmers to build tanks. Neither did anyone else. The stakes: industrial catastrophe. On June 22, 1941, when Operation Barbarossa shattered the pre-dawn silence across a 1,800-mile front, the Soviet Union possessed the world's largest tank force, 23,000 armored vehicles. But within 6 months, the Wehrmacht would capture or destroy over 20,000 of them. More catastrophically, German forces seized territory containing 85% of Soviet aircraft production facilities, 9 of 11 major tank factories, 60% of coal production, and 70% of steel manufacturing capacity. The numbers told a story of industrial annihilation. By September 1941, the Soviet Union had effectively lost 40% of its GDP, 60% of coal output, and 58% of steel production. The Kharkov tractor plant, birthplace of the T-34, sat in the path of Army Group South. The Kirov plant in Leningrad faced encirclement. The Stalingrad tractor factory would soon have German artillery within range of its assembly lines. Soviet industrial planners faced a calculation that should have ended in surrender. Defend the factories and lose them to German occupation, or evacuate them and lose months of production during the most critical period of the war. Either choice appeared fatal. The Wehrmacht was advancing 30 miles per day. The Red Army was hemorrhaging 5,000 tanks per month. Without continuous production, the mathematics were brutal. The Soviet Union would run out of armor before winter. The prevailing wisdom among Western military observers was unambiguous. The U.S. military attaché in Moscow cabled Washington with an assessment shared by British intelligence. The Soviet Union would collapse within 6 to 8 weeks. German High Command planned for victory by October. Their timetable allowed for the capture of Moscow, the destruction of Soviet military capacity, and the return of most Wehrmacht units to Germany before winter. Tank production, they calculated, would become irrelevant once the campaign ended. The Germans understood industrial warfare. Their own factories represented the pinnacle of engineering precision. Quality-controlled production lines staffed by skilled craftsmen, building technically superior machines like the Panzer IV and the soon-to-appear Panther and Tiger tanks. Each German tank was a masterpiece of metallurgy, featuring complex transmissions, precision optics, and armor plate that met exacting specifications. This superiority wasn't theoretical. In the opening weeks of Barbarossa, German tank crews destroyed Soviet armor at rates exceeding 10 to 1. A single panzer division could annihilate an entire Soviet mechanized corps. The tactical and technical dominance appeared overwhelming. Yet buried in those statistics was a Soviet advantage no one yet understood: crude mathematics. The Soviet Union had standardized on 3 tank chassis: the T-34 medium, the KV-1 heavy, and the T-70 light. German production was fragmented across dozens of variants, each requiring unique parts, specialized labor, and artisanal precision. Soviet tanks were designed not for perfection, but for mass production. Every component had been engineered with one question: can a minimally trained worker make this quickly? The answer would determine whether the Soviet Union survived. Section 1. The evacuation begins August 7, 1941, 04:30 hours. Kharkov, Ukrainian Soviet Socialist Republic. Plant director Alexander Morozov received a telegram that changed modern warfare. Evacuate factory number 183. Destination Nizhny Tagil. Timeline immediate. Priority absolute. Morozov stared at the words. Factory number 183 occupied 140 acres. It contained 10,550 machine tools, ranging from massive 100-ton hydraulic presses to precision lathes. It employed 8,000 skilled workers, many with decades of experience. The plant produced V2 diesel engines, 76.2 Methyla guns, transmissions, armor plate, and assembled complete T-34 tanks. It was not a factory, it was an industrial ecosystem. The telegram ordered him to dismantle this ecosystem, load it onto trains, transport it 1,500 miles east across a transportation network, simultaneously moving 2.5 million soldiers to the front, and rebuild it in an empty field before winter, all while maintaining production. The timeline was impossible, the logistics were impossible, everything was impossible. But German forces were 120 miles away. Morozov called his senior engineers into an emergency meeting at 05 Sagrum. Chief designer Mikhail Koshkin had died the previous year, but his deputy Leonid Rubinov understood the T-34's production requirements better than anyone. Tool shop supervisor Viktor Petrenko knew which machines were critical and which could be sacrificed. Personnel director Elena Kostina would have to identify which workers were essential and convince them to abandon their homes. The conventional wisdom in factory relocation was methodical: create detailed inventories, carefully disassemble machinery, properly crate components, maintain documentation, ensure orderly loading. This process typically required 6 months for a facility 1/10 the size of factory number 183. They had 3 weeks. "We don't have time for proper procedure," Morozov told his team. "We're going to cut every machine from its foundation, drag it to the rail siding, load it onto whatever train car fits, and send it east. Documentation follows later, if at all. Workers ride with the machinery. Families follow on civilian trains, if space exists." Rubinov pointed out the obvious problem. Half our workers will desert to stay with their families. The other half don't know where Nizhny Tagil is. "Then we tell them," Morozov replied. Nizhny Tagil or German occupation. Those are the choices. On August 8th, the factory horn sounded at dawn, not the normal work call, but a continuous blast that meant emergency assembly. 8,000 workers gathered in the main hall. Morozov climbed onto a half-finished T-34 hull and explained what was about to happen. The factory was being evacuated. Every worker with critical skills would go east. Families would follow as space allowed. Personal belongings, 20 kilograms per person. Departure, within days. The silence that followed lasted 15 seconds. Then the questions erupted. Where exactly? Housing? Food? What about our families? What about our homes? Morozov had no good answers. Nizhny Tagil has a tractor factory. We're merging with it. The state will provide housing, eventually. Food will be rationed, like everywhere. Your families will be evacuated when trains are available. Your homes will be here when we return, if the Germans don't destroy them. The brutal honesty worked better than false promises. These were Soviet workers in 1941. They understood the stakes. Either they rebuilt the factory in the Urals, or the Wehrmacht would parade through Moscow by October. Personal comfort didn't factor into that equation. The dismantling began immediately. Acetylene torches cut machine foundations. Cranes lifted 40-ton presses onto flat cars. Smaller tools were thrown into wooden crates without inventory. Workers discovered that proper documentation required more time than actual disassembly, so they stopped documenting. Chalk marks on machines indicated which department they came from. That would have to suffice. Rail cars arrived in a steady stream. Ore cars, boxcars, flat cars, tanker cars, anything that rolled. Some were still full when they arrived. Workers unloaded coal, ore, grain, whatever, dumping it beside the tracks. The rail yard became a mountain of abandoned cargo. Every car that could carry machinery went east. Everything else was left behind. By August 11th, the factory was operating on morning shifts only, using machines that would be dismantled that afternoon. T-34s rolled off assembly lines at 08 WAM. By 16, the assembly line itself was being loaded onto trains. Production and evacuation occurred simultaneously in the same physical space, creating organized chaos that somehow generated results. The workforce fractured along predictable lines. Skilled machinists, welders, and engineers were designated Priority 1. They would definitely go east. Semi-skilled workers were Priority 2. They'd go if space allowed. Unskilled laborers were Priority 3. They'd be recruited locally in the Urals. This brutal calculus meant families were separated, with skilled fathers going east, while wives and children waited for evacuation that might never come. Elena Costina spent 18-hour days managing this human logistics nightmare. A machinist with 25 years' experience begged to stay because his wife was 8 months pregnant. Costina denied the request. His skills were irreplaceable. A 19-year-old welder wanted to bring his mother and 3 younger siblings. No space. He could go alone or not at all. He chose to go. By August 15th, 26,000 rail cars had evacuated industries from Ukraine. Factory number 183 accounted for 722 of them. The trains departed every 3 hours around the clock. Some cars were properly secured. Others had machinery sitting loose on flatbeds, held down by rope and prayer. Workers rode alongside the equipment, sleeping on tool crates, eating whatever food they'd brought. The journey east averaged 12 days, when it went smoothly. Trains were diverted for military traffic. Cars were uncoupled and rerouted to wrong destinations. Some trains simply stopped in the middle of nowhere, waiting for tracks to clear. Workers ate through their food supplies, then foraged at station stops, then went hungry. One trainload of equipment from factory number 183 arrived in Novosibirsk, 500 miles north of the intended destination, because a railway dispatcher couldn't read the destination card. The machinery sat in a rail yard for 3 weeks before someone realized the error and rerouted it. By then, the workers had scattered, assuming the evacuation had failed. But most trains reached Nizhny Tagil, and what they found there made Kharkov look like paradise. Section 2. Building in the Wasteland. October 12, 1941. Nizhny Tagil, Ural Mountains. Temperature -5 degrees Celsius. First snow expected within days. Rail cars containing factory number 183's machinery sat on sidings stretching 3 miles from the existing Dzerzhinsky Ural railcar factory, which was supposed to be their new home. There was one problem. The existing factory was already at 150% capacity producing railcars for the war effort. There was no room for 10,000 machine tools and 8,000 additional workers. Local officials had prepared exactly 0 housing, erected 0 additional factory buildings, and allocated 0 resources for the incoming surge. The machinery would have to be installed outdoors. This decision violated every principle of industrial engineering. Machine tools require level, stable foundations. Precision lathes operate within tolerance measured in thousandths of an inch. Impossible when the ground is frozen mud. Hydraulic presses need protection from the elements. Electrical equipment short circuits when exposed to rain and snow. Assembly lines require enclosed spaces to maintain quality control. None of that mattered. Winter was coming. The Red Army needed tanks. The machinery would be installed wherever space existed, and production would begin immediately. Unloading began on October 15th. Workers who had spent 2 weeks on trains without adequate food or rest now faced the task of manhandling multi-ton machines from rail cars to installation sites. They had minimal cranes, inadequate rigging, and no detailed plans. Some machines were lowered onto temporary wooden foundations. Others were placed directly on the frozen ground. Former collective farm workers from the Ural region arrived to supplement the workforce. Recruited by local party officials with promises of jobs and rations. These new recruits had never seen a factory. Many had never seen a tank. They couldn't read technical drawings, didn't know metric measurements, and had no industrial training whatsoever. Training them required two things the factory didn't have: time and instructors. The skilled workers from Kharkov were desperately needed on the production floor. They couldn't spend weeks teaching basic metalworking. So the training program was compressed into 48 hours. Here's a lathe. Here's how you turn it on. Here's what parts you'll be making. Now do it 500 times until it's correct. Valia Korzhenko was 19 years old when she arrived at what would become Tankograd. She'd worked in her village's collective farm office. Clerical work, basic literacy, nothing mechanical. On October 20th, she was assigned to a welding station. Her training consisted of watching an experienced welder for 2 hours, then being handed a torch and told to practice on scrap metal. By October 25th, she was welding armor plate onto T-34 hulls. She didn't know if the welds were strong enough. Nobody had time to check every weld. If the tank didn't fall apart during delivery, the weld was deemed adequate. Conditions were medieval. The factory operated 24 hours daily, but only half the machinery had electric lighting. Night shift workers held flashlights in their mouths while operating lathes. The temperature inside the partially roofed assembly areas hovered around freezing. Warmer than outside, but not by much. Workers wore every layer of clothing they owned, then added felt boots and sheepskin coats scrounged from local supplies. The workforce was transforming. In Kharkov, factory number 183 had employed primarily men aged 25 to 45 with years of experience. By November 1941, the Tankograd workforce was 50% women, 15% boys under 18, and 15% men over 50, or with medical conditions excluding them from military service. The remaining 20% were the skilled male workers evacuated from Kharkov, and they were leaving in a steady stream, conscripted into the army despite their critical roles. Elena Kostina fought a losing battle to retain key personnel. A master toolmaker would be declared essential to production on Monday, then conscripted by a Red Army recruiter on Tuesday. She'd appeal to the district military commissar who'd overrule the conscription until a higher authority reinstated it. Some skilled workers simply vanished, drafted into penal battalions without notice. Others volunteered, overwhelmed by guilt at working in a factory while the Wehrmacht closed on Moscow. This personnel hemorrhage meant the workforce was constantly training replacements. A skilled machinist would spend 3 months training an apprentice to minimal competence, then get conscripted. The apprentice, now the most experienced person at that station, would begin training a new recruit. Quality declined with each generation of knowledge transfer, yet somehow production began. The first T-34 hull emerged from the Tankograd assembly line on November 27, 1941, incomplete, unpainted, missing several subsystems, but recognizably a tank. Workers gathered to stare at it. Some cried. After 3 months of impossible logistics, brutal working conditions, and constant chaos, they had produced proof that rebuilding was possible. By December 1st, the factory had completed 25 T-34s. All of them were immediately loaded onto rail cars and sent west to the Moscow front, where German forces were within 15 miles of the Kremlin. The tanks arrived unpainted. There was no time for that luxury. Crews drove them directly from the rail depot to defensive positions. Most were destroyed within a week. But the Battle of Moscow consumed armor faster than either side could replace it, so even incomplete tanks mattered. The bottlenecks were everywhere and constantly shifting. Week 1, no V2 diesel engines because the engine plant hadn't been rebuilt yet. Tanks sat as incomplete hulls, waiting for power plants that arrived in dribs and drabs. Week 2, engines arrived, but transmissions were delayed. Week 3, transmissions solved, but 76.2 mm guns were stuck in transit. Week 4, guns arrived, but optical sights were missing. Tanks went to the front, with makeshift aiming systems cobbled from available materials. The Germans had assumed Soviet tank production would collapse during the evacuation. Their intelligence estimates predicted a 70% reduction in output, lasting at least 6 months. They were correct about the reduction. Production in the second half of 1941 fell to 6,590 tanks, compared to 2,800 in the first half. But what German intelligence failed to predict was the Soviet willingness to sacrifice quality, safety, working conditions, and human comfort to maintain any production at all. A Daimler-Benz engineer inspecting Stalingrad in 1943, after its capture was expected but never occurred, would have declared the facility criminally negligent. Machinery operating without safety guards, workers handling molten metal without protective equipment, cranes lifting loads beyond their rated capacity, apprentices performing tasks requiring years of training, zero compliance with industrial safety protocols developed over decades. But Daimler-Benz built approximately 3,000 tanks during the entire war. Stalingrad would build 18,000. Section 3. The philosophy of expendability. The fundamental insight driving Soviet tank production was brutal, controversial, and mathematically correct. Tanks were going to be destroyed quickly, so build them to survive exactly long enough to reach the battlefield. In January 1942, the Red Army's automotive department published internal data that shocked even Soviet planners. The average operational lifespan of a T-34 on the Eastern Front was 6 months from delivery to destruction. During active combat operations, the survival time averaged 14 hours. This data invalidated decades of engineering assumptions. Why build a transmission guaranteed for 5,000 kilometers when the tank would be destroyed after 200 kilometers? Why use hardened steel screws when mild steel screws would fail at kilometer 1,000? But the tank would be dead by kilometer 300. Why precision machine components to exacting tolerances when battlefield effectiveness was measured in can it move and shoot, rather than does it meet specifications? The Americans and Germans approached this problem from opposite directions, and both were wrong. American engineers overbuilt the M4 Sherman, creating a tank that could theoretically operate for 8,000 miles and required 10,000 man-hours to construct. German engineers built masterpieces. The Panther required 55,000 man-hours. The Tiger I needed 300,000 man-hours. Both philosophies prioritized crew survival, mechanical reliability, and longevity. The Soviets built disposable weapons, crewed by disposable soldiers. This wasn't cruelty, it was mathematics. Consider transmission production. A German transmission for a Panzer IV required 180 precision-machined parts, assembled by skilled workers, tested for 48 hours, and certified to operate for 5,000 kilometers. Soviet transmissions for the T-34 used 112 parts, many crudely stamped rather than machined, assembled by semi-skilled workers, tested for 4 hours, and guaranteed for 1,500 kilometers, which was 1,300 kilometers longer than necessary. The cost savings compounded across every system. Armor plate didn't need smooth welds. Adequate welds would suffice. Interior accommodations were irrelevant. The crew would be dead in 2 weeks anyway. Paint was decorative nonsense. Bare metal or minimal primer saved labor hours. Rubber road wheels were ideal, but steel wheels worked adequately when rubber was unavailable. This zen of shoddiness, as one post-war Western analyst called it, allowed Soviet factories to reduce T-34 production time from 8,000 man-hours in 1940 to 3,700 man-hours in 1943. The cost per tank dropped from 269,500 rubles in 1941 to 135,000 rubles in 1943, while German tank costs were increasing due to complexity. The human cost of this philosophy was deliberately calculated into the system. T-34 crews had a life expectancy measured in weeks. The tank's interior was cramped, poorly ventilated, inadequately padded, and deafeningly loud. When hit, the T-34 tended to catastrophically explode due to stored ammunition and fuel positioning, killing the crew instantly rather than allowing escape. German tankers called the T-34 a grave on tracks. They were correct. But the Soviet military-industrial complex had performed a calculation. Crew comfort and safety required engineering time, production complexity, and material resources that could instead produce additional tanks. Given the choice between 100 tanks with 95% crew survival rate or 200 tanks with 50% crew survival rate, the mathematics favored more tanks. This approach horrified Western observers and proved devastatingly effective. By 1943, the Soviet Union was producing 24,000 tanks per year. Germany produced 6,000. The United States produced 29,000, but was fighting on 2 fronts and supplying allies. The USSR concentrated its entire output against Germany. Quality metrics told the story. In 1943, captured T-34s underwent evaluation at the Aberdeen Proving Ground in Maryland. American engineers were simultaneously impressed and appalled. The V2 diesel engine was brilliantly designed, simple, powerful, reliable enough. The transmission was adequately functional. The armor was well sloped and effective. The 76.2mm gun was excellent, but the finish quality was abysmal. Welds were crude, interior paint was absent. The turret rotation mechanism sparked dangerously. The vision ports were poorly sealed. The radio was primitive when present at all. Most T-34s lacked radios entirely, coordinating via flag signals. The crew accommodations made a sardine can look spacious. The American evaluators concluded, "This tank embodies the contradictions of Soviet industrial philosophy. It is simultaneously an excellent tank and a horrible tank. No American crew would accept its working conditions. But if we built tanks this crudely, we could produce 150,000 per year rather than 30,000. The Germans reached similar conclusions after examining captured specimens. A 1942 Panzer Commission report noted, "The T-34 represents a design philosophy completely alien to German engineering principles. Every component is simplified to the minimum functional level. This results in a vehicle that is crude, uncomfortable and unpleasant, but also cheap, simple to maintain, and producible in vast quantities by unskilled labor. We cannot replicate this approach without abandoning our quality standards, but those quality standards may cost us the war." The report was prophetic. In 1943, Germany produced 5,966 Panther tanks. engineering marvels featuring advanced targeting systems, powerful guns, sophisticated suspensions, and armor layouts inspired by the T-34. Each Panther cost 3 times what a T-34 cost and required 4 times the labor hours. The Soviet Union produced 15,000 T-34s that year, vehicles that were inferior to the Panther in almost every technical category except the one that mattered. They existed in overwhelming numbers. Soviet production coordinators understood a principle that German engineers refused to accept. Perfect is the enemy of adequate. A Panther that took 200 hours to complete was inferior to 4 T-34s that took 50 hours each, even though the Panther could destroy any individual T-34 in combat. The mathematics were brutal. 1 Panther versus 4 T-34s resulted in 1 destroyed Panther and 3 surviving T-34s. This played out in brutal clarity at Kursk in July 1943. Germany deployed 230 Panthers, the technical pinnacle of tank design. The Soviets deployed 1,300 T-34s in that sector alone, crude but adequate. Panthers suffered from mechanical breakdowns, with 162 out of commission within the first week due to transmission and engine failures caused by insufficient testing. The T-34s broke down at similar rates, but the Soviets had 3 backup tanks for every broken Panther. The casualties were lopsided. The Germans destroyed approximately 1,500 Soviet tanks at Kursk. Soviet forces destroyed roughly 300 German tanks, but the Red Army ended the battle with more operational armor than they started with, because new T-34s arrived from Stalingrad and other factories faster than old ones were destroyed. The German approach assumed tank warfare was a series of technical duels where superior engineering triumphed. The Soviet approach recognized it as industrial attrition, where production capacity determined outcomes. Both sides were fighting with internally consistent logic. But only one logic was compatible with winning a war of national survival. Section 4. The human machines. The workers building tanks at Stalingrad were themselves transformed into industrial components, human beings converted into biological machinery, optimized for single functions. By 1943, Stalingrad employed 60,000 people under one roof, or more accurately, under one partially covered roof. The facility covered 575 acres, making it the largest single-site production facility in the world. For comparison, the Ford River Rouge complex, America's largest industrial facility, employed 100,000 workers but spread across multiple buildings and product lines. Chrysler's Detroit tank arsenal, purpose-built for M4 Sherman production, employed 19,500 workers. Stalingrad concentrated more armor production in one facility than any other location in human history. The workforce demographic was unlike any industrial facility before or since. The 1944 breakdown, 58% women, 12% boys, aged 14 to 17, 15% men over 50 or medically unfit for military service, and 15% male workers of military age who held critical positions. 17-year-old Dmitry Volkov operated a turret casting station from February 1943 until war's end. He worked 12-hour shifts, 6 days per week. His job, use an overhead crane to pour molten steel into turret molds, then move the molds to cooling stations. The crane had been rated for loads up to 18 tons. The turret castings weighed 23 tons, but replacement cranes weren't available, so Volkov operated the equipment 30% beyond capacity, knowing that if the crane failed and dropped the load, he'd be killed instantly by either the falling turret or the molten metal spillage. Volkov survived the war. His crane didn't. It failed in April 1945, dropping a turret casting onto the factory floor. The replacement turret was cast the next day using a different crane. Production delays, 6 hours. Women like Valia Korchenko, the former collective farm clerk turned welder, made up the majority of skilled positions by 1943. She welded armor plate 10 hours per day, 6 days per week, for 3 years. Her hands developed permanent tremors from the vibration of the welding equipment. Her vision was damaged by inadequate eye protection. Welding goggles were in short supply, so workers often welded while squinting. Her hearing was destroyed by the industrial noise levels that exceeded 100 decibels continuously. Post-war medical examinations of Stalingrad workers revealed systematic health devastation. 68% suffered permanent hearing damage. 42% had respiratory conditions from metal dust and welding fumes. 31% had repetitive motion injuries. 23% showed heavy metal poisoning from industrial chemical exposure. The average life expectancy of workers who spent 1942 to 1945 at Stalingrad was 58 years, 15 years below the Soviet average. But they built tanks. The daily caloric allocation told the story of priorities. Defense industry workers received 800 grams of bread daily, compared to 400 grams for the general population. They were entitled to 1,600 calories minimum, substantially below the 2,500 to 3,000 calories required for heavy industrial labor, but better than the near-starvation rations in Soviet cities. Workers were technically entitled to meat 3 times per week. In practice, meat appeared monthly at best. Potatoes, cabbage, and grain formed the dietary staples. The housing was no better. Workers lived in barracks hastily constructed from timber, when they lived in barracks at all. In 1942, many workers lived in converted rail cars, sleeping in shifts in the same bunks. 6 workers per rail car, sleeping in 2 rotations of 3, so that beds were warm when you climbed into them because someone else had just vacated them. Privacy was a bourgeois concept irrelevant to wartime production. Medical care was basic. Bandage minor injuries, send major injuries to overwhelmed hospitals, eulogize the dead. The factory hospital handled approximately 300 industrial accidents per month. Crushed fingers, severed hands, burns, toxic exposures, falling injuries. Fatal accidents occurred weekly. The factory memorial eventually listed 1,247 workers who died from workplace accidents during the war years, but production metrics improved continuously. In December 1941, Stalingrad produced 25 tanks. January 1942, 122 tanks. June 1942, 504 tanks. December 1942, 749 tanks. Peak production occurred in July 1944, 1,087 tanks in 31 days, 35 per day, or 1 tank every 41 minutes. This was possible only through complete abandonment of normal industrial safety, quality control, and human welfare standards. Workers operated machinery while exhausted, malnourished, and inadequately trained. Assembly lines moved at speeds that guaranteed mistakes, but catching mistakes required inspection time, and inspection time reduced output. So tanks rolled off the line with known defects, shipped to the front, and either functioned adequately or failed immediately. Failed tanks were abandoned. Working tanks killed Germans. The psychological toll was carefully managed through propaganda and coercion. Workers who exceeded production quotas were designated heroes of socialist labor and awarded extra rations. Workers who failed to meet quotas faced reduced rations, reassignment to worse positions, or accusation of sabotage, which carried implications of treason. But genuine motivation existed beyond coercion. Maria Oktyabrskaya, a 38-year-old telephone operator whose husband died at the front, donated her life savings, 50,000 rubles, to purchase a T-34, then demanded to be trained as its driver. Stalin personally approved the request. Oktyabrskaya's tank, named Fighting Girlfriend, destroyed German positions in multiple engagements before she was killed in January 1944. Her story was publicized nationally to encourage similar sacrifices. Thousands of civic organizations, Workers' collectives and patriotic societies purchased T-34s with pooled funds. Factories would ceremonially present these tanks to crews brought from the front for the occasion, creating a direct emotional connection between producers and users. Workers saw soldiers receiving their tanks, heard first-hand accounts of combat, understood viscerally that every hour of production saved Soviet lives. This bond between factory and front line was unique to the Soviet system. American workers building Shermans never met the crews who'd use them. German workers producing Panthers operated in disconnected industrial silos. Soviet workers at Stalingrad had regular contact with tank crews. Soldiers came to the factory for repairs, shared combat stories, and created human relationships with the producers. When a T-34 returned from the front for repairs, engines replaced, armor re-welded, battle damage fixed, workers saw the effectiveness of their labor in physical form. Blast marks on armor meant the tank had survived German hits. Empty shell casings meant the crew had fired its weapons. Bloodstains meant Soviet soldiers had bled inside their product. It was visceral, immediate, and motivating in ways that abstract production quotas could never be. The Germans never understood this psychological dynamic. Their system separated production from utilization, treating factories as industrial facilities rather than as extensions of the battlefield. Efficiency, quality, and technical perfection were the goals, not emotional connection to the ultimate users. The Soviets understood that production was warfare by other means. Every worker was a soldier in the industrial battle. The factory was a frontline position, and victory would be determined not by who built the best tanks, but by who built the most tanks fast enough. Section 5. The German Response, November 18, 1941. Headquarters, 2nd Panzer Army, Eastern Front. General Oberst Heinz Guderian authorized the establishment of a special Panzer Commission to assess the T-34 threat and recommend responses. The commission spent 3 weeks examining captured T-34s, interviewing German tank crews, analyzing combat reports, and consulting with engineering specialists. Their December report was classified most secret and distributed to 15 copies, because its conclusions were devastating to German assumptions about technical superiority. The report's opening section summarized the tactical reality. The T-34 is superior to any German tank currently in service. Its 76.2 meter gun can penetrate the frontal armor of Panzer III and I-4 at ranges exceeding 1,500 meters. Our 50mm and 75mm guns cannot reliably penetrate T-34 frontal armor at any practical combat range. The T-34's sloped armor provides effective thickness of 90mm at the glacis, equivalent to 140mm of vertical armor. Its wide tracks provide mobility in mud and snow where our tanks become immobilized. Its diesel engine is less prone to fire than our gasoline engines. The engineering assessment was equally concerning. The T-34 embodies a design philosophy fundamentally different from German practice. Where we optimize for maximum performance, Soviet designers optimize for adequate performance with maximum simplicity. The result is a vehicle that is cheaper to produce, faster to build, simpler to maintain, operable by less trained crews, and producible by less skilled labor. The report's conclusion recommended 3 options. Option 1. Directly copy the T-34 design, manufacturing it under license. Option 2. Incorporate T-34's best features, sloped armor, long gun, wide tracks, into new German design. Option 3. Increase production of existing designs and accept inferior performance. Guderian endorsed Option 1, direct copying. He argued that German technical pride was irrelevant when facing potential defeat. If the T-34 was the superior tank, Germany should build T-34s. The Waffenamt, Army Weapons Agency, rejected this recommendation for multiple reasons. First, the T-34's diesel engine required aluminum alloys Germany couldn't produce in sufficient quantity. The Soviet V-2 engine used aluminum engine blocks. Germany's aluminum production was allocated to aircraft. Second, the T-34's sloped armor required large steel castings and heavy forming presses. German armor production relied on face-hardened plate, a completely different metallurgical process. Third, copying the T-34 meant abandoning existing production infrastructure and retraining the workforce. The transition period would reduce output precisely when increased output was critical. Fourth, and unstated but crucial, German engineering pride couldn't accept building inferior Soviet designs. The Waffenamt insisted German engineers could design a better tank than Soviet engineers. This assumption would prove fatal. Instead, Germany pursued option 2, new designs incorporating T-34 lessons. Daimler-Benz and MAN received contracts to design 30 to 35-ton medium tanks. The resulting designs, Daimler-Benz's VK3002D and MAN's VK3002M, would become the Panther. The Panther incorporated the T-34's sloped armor and long overhanging gun, but it added German complexity, a sophisticated fire control system, a powerful Maybach engine, interleaved suspension wheels, and precision machining throughout. The Panther was technically superior to the T-34 in almost every measurable category. It was also vastly more expensive, complex, and time-consuming to build. Initial Panthers required 55,000 man-hours to construct, 18 times longer than a T-34. Even after production optimizations, the Panther never dropped below 35,000 man-hours, still 10 times the T-34's requirement. Production numbers reflected this complexity. Germany planned to produce 600 Panthers monthly. Actual production peaked at 380 per month in July 1944. Total Panther production, 5,176 vehicles by war's end. Meanwhile, the Soviet Union produced 35,119 T-34-76 and 29,430 T-34-85 models during the war, a total of 64,549 T-34s. Even in 1941, the worst year of Soviet production, the USSR built 2,996 T-34s, while Germany built 2,175 Panzer IIIs and IVs combined. The production gap widened catastrophically. In 1942, the Soviets produced 24,446 tanks. Germany produced 6,180. In 1943, Soviets 24,089, Germans 12,063. In 1944, Soviets 28,963, Germans 18,956. The Soviet advantage wasn't marginal, it was overwhelming. German quartermasters performed grim calculations. To achieve parity with Soviet armor on the Eastern Front required either increasing German production to Soviet levels, impossible without abandoning quality standards, achieving kill ratios of 3-to-1 or higher, possible early in the war, increasingly difficult by 1943, or reducing Soviet production, impossible, the factories were out of Luftwaffe range. All three options were unattainable. Germany's industrial capacity was smaller than the USSR's. German quality standards prevented Soviet-style mass production, and Soviet factories, relocated beyond the Urals, were invulnerable to German attack. The Wehrmacht adapted tactically. German doctrine shifted toward defensive positions where technical superiority could maximize kill ratios. Panther and Tiger tanks fought from prepared positions, ambushing Soviet armor at long ranges where German optics and fire control provided advantages. This worked in individual engagements, but strategic defeat was inevitable when the Red Army could replace losses faster than Germany could inflict them. By Kursk in July 1943, the Wehrmacht deployed 230 Panthers and approximately 2,300 tanks total. The Soviets fielded 5,128 tanks in the defensive positions, including 1,300 T-34s concentrated where German armor would attack. The Germans achieved local tactical victories, destroying Soviet tanks at favorable ratios. But when the battle ended, the Red Army retained operational superiority because replacement T-34s were arriving from Stalingrad faster than destroyed ones could be removed from the battlefield. German generals blamed strategic errors, tactical mistakes, inadequate air support, and bad luck. But the fundamental cause was industrial. Germany's production philosophy prioritized quality over quantity, and in a war of attrition, quantity determined outcomes. Section 6. The Climax. Berlin, 1945. April 26, 1945. Berlin, Germany. 1st Guards Tank Army advanced through the rubble of Berlin's eastern suburbs, spearheaded by 482 T-34-85s, the improved variant mounting an 85mm gun. These tanks had been built at factories throughout the Soviet Union: Stalingrad, Gorky, Sverdlovsk, Omsk. Some had rolled off production lines 3 months earlier. Others were battle-scarred veterans of campaigns spanning 1,500 miles. General Oberst Gotthard Heinrici commanded the defense of Berlin. His Panzerwaffe consisted of approximately 70 operational tanks, a mixture of Panthers, Panzerwaffes, and Tiger IIs. On paper, each German tank was superior to the T-34-85. The Tiger II's 88mm gun could destroy a T-34 at any range. Panther armor was impervious to the 85mm gun frontally, but there were 70 German tanks and 482 Soviet tanks, plus 1,500 additional T-34s approaching from other directions. The mathematics were inescapable. Heinrici understood industrial reality. We are fighting the Soviet Union's factories, not merely their armies. Every tank we destroy is replaced within days. Every tank we lose is irreplaceable. This is not a military battle. It is an industrial execution. He was correct. On April 26th alone, Stalingrad produced 35 additional T-34s. The Gorky factory produced 18. Sverdlovsk produced 22. Total Soviet production that day: 87 new tanks, more than the entire Berlin garrison possessed. The street fighting consumed armor catastrophically. Soviet tactics relied on numerical superiority and acceptable casualties. T-34s advanced down boulevards, accepting losses from Panzerfausts and remaining German tanks until enough survived to overwhelm positions. German defenders destroyed individual T-34s repeatedly, only to face more T-34s the next hour. By April 30th, the 1st Guards Tank Army had lost 274 T-34s to combat, but reinforcements had brought their strength to 441 operational tanks. They had more armor at the end of the battle than at the start, despite horrific casualties. The final German defenders in the Reich Chancellery district fought with whatever remained: 2 Panther tanks, 7 Panzer IV, 43 anti-tank guns, and approximately 2,000 Panzerfausts. They faced over 1,000 Soviet tanks from multiple armies converging on the city center. The last recorded German tank was destroyed on May 2, 1945, a Panther commanded by an SS Hauptsturmführer whose crew had fought continuously since April 24th. The Panther had destroyed 11 T-34s before a 152mm howitzer shell struck it from the side. The crew attempted to escape. 3 were killed by Soviet infantry. 1 survived as a prisoner. By May 8th, when Germany formally surrendered, the Soviet armed forces possessed 24,000 operational tanks. The Wehrmacht had approximately 1,200, of which only 400 were operational. The Red Army had more T-34s available on Victory Day than Germany had tanks of any type operational at any point during 1945. The final production tallies revealed the stark reality. Soviet Union, 1941 to 1945, T-34 variants, 64,549 tanks. Other tanks, KV, I-Series, light tanks, 34,601 tanks. Total, 19,150 tanks. Germany, 1939 to 1945, all tank types combined, 26,925 tanks. Assault guns and tank destroyers, 18,381 vehicles. Total fully tracked AFVs, 45 with 306 vehicles. The ratio was decisive. The Soviet Union produced 2.2 times more armored vehicles than Germany, despite occupying less industrial territory, suffering greater combat losses, and enduring far worse starting conditions. The difference wasn't explained by resource availability. Germany controlled European steel production exceeding Soviet capacity. German engineering sophistication was world-leading. German infrastructure was superior. German workforce education was higher. The difference was philosophy. Germany built masterpieces, the Soviet Union built enough. Resolution, the mathematics of victory. The story of Stalingrad and Soviet tank production wasn't about technical superiority, engineering brilliance, or tactical genius. It was about industrial arithmetic and the ruthless willingness to sacrifice everything: quality, safety, human welfare, individual lives, to achieve one goal: adequate production in overwhelming quantity. The final statistics: Stalingrad, 1941 to 1945. Workers employed, 60,000 at peak. T-34 variants produced, 28,952 tanks. T-34-76 production, 15,014 tanks. T-34-85 production, 13,938 tanks. Worker fatalities, 1,247, 4.2% of peak workforce. Working conditions, medieval, production cost per tank, 135,000 rubles, 1943 average. Man-hours per tank, 3,700 hours, 1943 average. German tank production, 1941 to 1945. Panzer IV variants, 8,800 tanks. Panther variants, 5,976 tanks. Tiger IX variants, 1,347 tanks. Tiger II variants, 492 tanks. Production cost per Panther, 325,000 Reichsmarks. Man-hours per Panther, 35,000 hours. The comparison was brutal. Stalingrad alone produced more tanks than all German Panther production. One Soviet factory, staffed primarily by women, teenagers, and collective farmers, outproduced the entire German precision engineering establishment. The human cost was equally stark. Soviet industrial workers endured conditions that would have triggered strikes or rebellions in any Western democracy. They worked 12-hour shifts, 6 days weekly, for years. They lived in barracks or rail cars. They ate marginal rations. They suffered injuries at rates that modern safety inspectors would consider criminal negligence. They died from industrial accidents, exposure, malnutrition, and exhaustion. But they built tanks, and those tanks drove to Berlin. Ivan Likachev, the foreman who stood in an empty field in July 1941, staring at rail cars full of dismantled machinery, survived the war. In May 1945, he received the Hero of Socialist Labor Medal. He didn't attend the ceremony. He was too busy supervising continued production. The war had ended, but the factory kept building tanks. The Soviet Union wasn't finished building armor until it possessed overwhelming superiority over all potential enemies. When interviewed in 1946 about the evacuation and reconstruction, Likachev provided a characteristically Soviet response. The task was impossible. Everyone understood this. We did it anyway, because the alternative was fascism. If you're asking whether we could have done better, probably. If you're asking whether anyone else could have done as well, no. The Germans never expected Soviet farmers to build tanks. They assumed industrial capacity required skilled labor, modern facilities, adequate resources, and proper infrastructure. The evacuation and reconstruction proved that industrial capacity required only two things: functional machinery and the willingness to accept any price to make it work. The fundamental lesson wasn't about tank design, combat tactics, or military strategy. It was about industrial economics. In total war, production capacity determines outcomes. Technical superiority matters in individual engagements. Quality matters in peacetime competition. But in existential conflict, quantity trumps quality when the quantitative advantage becomes overwhelming. The Soviet Union produced 100,000 tanks during World War II. Germany produced 27,000. The ratio, 3.7 to 1, determined the war's outcome more definitively than any battle, general, or weapon system. Stalingrad was never about building the best tanks. It was about building enough tanks. The farmers, women, and teenagers who made it possible didn't create an engineering miracle. They created an industrial phenomenon, adequate weapons in overwhelming numbers, produced under conditions that defied every assumption about what industrial production required. The Germans laughed at Soviet tank quality in 1941. They mocked crude welds, primitive interiors, and unsophisticated systems. They were still laughing in 1942 when Stalingrad's factories, surrounded by street fighting, continued producing tanks that rolled directly from assembly lines to defensive positions. By 1943, the Germans weren't laughing. They were calculating and realizing the mathematics led inevitably to defeat. By 1945, there was nothing left to calculate. Berlin's streets were filled with T-34s, built by people the Wehrmacht had dismissed as industrially irrelevant. The masterpiece Panther tanks, technical marvels that German engineers spent years perfecting, were destroyed by Soviet tanks assembled in 6 weeks by workers who'd never seen a factory before the war. The lesson was simple, brutal, and inarguable. Wars are won by those who can produce adequate weapons faster than enemies can destroy them. Everything else is commentary.